Covariant return types. Java SE5 adds covariant return types, which means that an overridden method in a derived class can return a type derived from the type returned by the base class method. The key difference between Java SE5 and earlier versions of Java is that the earlier versions would force the overridden version of process to return grain, rather than wheat, even though wheat is derived from grain and thus is still a legitimate return type. Covariant return types allow the more specific wheat return type. Designing with inheritance. Once you learn about polymorphism, it can seem that everything ought to be inherited, because polymorphism is such a clever tool. This can burden your designs. In fact, if you choose inheritance first when you're using an existing class to make a new class, things can become needlessly complicated. A better approach is to choose composition first, especially when it's not obvious which one you should use. Composition does not force a design into an inheritance hierarchy. But composition is also more flexible since it's possible to dynamically choose a type, and thus behavior, when using composition, whereas inheritance requires an exact type to be known at compile time. The following example illustrates this. A stage object contains a reference to an actor, which is initialized to a happy actor object. This means perform play, produces a particular behavior. But since a reference can be rebound to a different object at runtime, a reference for a sad actor object can be substituted in actor, and then the behavior produced by perform play changes. Thus you gain dynamic flexibility at runtime. This is also called the state pattern. See Thinking in Patterns, with Java, at www.mindview.com. In contrast, you can't decide to inherit differently at runtime. That must be completely determined at compile time. A general guideline is use inheritance to express differences in behavior, and fields to express variations in state. In the preceding example, both are used. Two different classes are inherited to express the difference in the act, method, and stage uses composition to allow its state to be changed. In this case, that change in state happens to produce a change in behavior. Exercise 16.3, following the example in transmogrify.java, create a Starship class containing an alert status reference that can indicate 3 different states. Include methods to change the states. This is an example of the state design pattern, wherein the object's behavior is state-dependent. The 3 states of an alert status object, to which the Starship class holds a reference, represent behaviors of the Starship. You switch the set status reference from one state to another to change the behavior of the Starship.